So, if you recall, last week we talked about implicit differentiation. Implicit differentiation involves deriving functions using dy dx and dx dx. So essentially what happens is you're going to have variables that can't be separated anymore. We have x tied to y and y tied to x, and they can't be broken apart. So if you look at this example here, you have x cubed y plus y cosine x equals 10. So essentially what's happening is x cubed and y can't be broken apart or taken away. So we're going to use the product rule to find their derivative. So recall the product rule says the first, so x cubed, times derivative of the second, the derivative of y becomes 1 dy dx, plus the second, which is y, times derivative of the first, so you get 3x squared. We derive x with respect to x, so you get dx dx. Correct. Plus the next part of the problem. So first times derivative of second. I know it's been a while. What's the derivative of cosine?
Negative sine.
Awesome. And this is variable, so you need dx dx. Plus the second, which is cosine, times derivative of the first, which is 1 dy dx, equals derivative of a constant. Okay, our goal is to rearrange all the terms so dy dx are on the left of the equals and the dx's become 1s and move to the right. So this is going to stay. The next part's going to move. So you get negative 3x squared y. This is going to move. So it's negative y sine x. So when you move it, it becomes positive y sine x. And cosine dy dx stays. GCF out dy dx. Divide yes, and then you're done. Did you lose your notes? You know I gave you guys notes for this. Did you lose them? Do you need a new one? Okay. Probably have an extra. You probably sorry. Realized you didn't one of them. So because I didn't send that number. Now the next one should be like. Mike was moving. I'll move Mike was. Oh, they're talking about moving his test. I'll move the last example from the other day. I need that. Yeah. Okay, find the derivative of sine x plus y. So now it's inside the angle with two variables. So, start with the outside. Derivative of sine is chain rule says outside derivative, inside stays the same, times the inside derivative. This is where your brackets are more important than ever. What's the derivative of x? 1 dx dx. What's the derivative of y?
Wait, it's still 1 and then just
Yeah.
1. Yeah, okay.
Equals product rule.
Y squared. Why is it? No, secant squared. X plus 2y dyx.
So first times the root of the second plus second times the root of the first. This does what with parentheses? So you get cosine x plus y plus cosine x plus y dy dx equals y squared secant squared x plus 2y tan x dy dx. We always want dy dx on the, so we got to move over the 2 tan x to y tan x. We don't want the cosine x plus y, so we move it. So you got dy dx, cosine x plus y, minus 2y tan x, equals y squared secant squared x minus cosine x plus y. Do you see why before I stressed so highly about putting parentheses around your trig angles? Because now you got that x plus y, so it needs parentheses. Making sure your brackets show distribution. And you just divide. We're going to divide by what's, yes, to isolate dy dx.
And you don't have to keep going. You stop right there.
Correct. And please do not cancel the cosine x plus y. Do not. They are in numerator and denominator jail because they're being subtracted in those. So you cannot cancel cosine x plus y. I promise on our quiz, someone will. That's what I'm saying. Like, it always happens. Like, I will sit here and say, do not. And then every time I'm like, no.
The last one is I didn't cancel the sequence. So I'm going to do it this time.
What is our test?
I'm hoping tomorrow.
How close are
I don't want to know.
Halfway through the non-calculator.
How
I haven't
bad
touched
are
the
they?
calculator. I wasn't here Friday, and then yesterday I had conferences like scattered all day.
Mr. Trinkle part next to me was like,
What?
so I was talking and Mr. Trinkle was on the basement.
So how bad are they so far?
They're not bad. Here you have 5 sine x times cosine y. It is a product rule. So it is the first.
Triple product.
It's not a triple.
Oh, okay.
This is the first, because the derivative of 5 would be 0. It's 0 out. Remember, coefficients on trig functions don't make a product rule. First times derivative of the second, so derivative of cosine, derivative of y. Yes. That's why I say it's so important to put the dx dx's, because otherwise we tend to forget the dy dx's when the angle is a y. So it's first times derivative of second times derivative of the inside, which is dy dx, plus the second times derivative of the first. So derivative of 5 sine x becomes 5 cosine x. Derivative of x is equals derivative of x, which is
Dx, which is 1.
yes. Clean it up. 5 times negative 1 is negative 5. Sine x, sine y, dy dx. 5 cosine x, cosine y. Equals 1.
Oh, it's one of the rules.
It is, but you don't have to do it if you don't want to. Subtract this over. It is.
No,
It's Casey. Okay. Thanks, Andrew. And then exactly, you divide by the negative 5 sine x sine y.
Okay.
These also do not cancel, simplify, or become tangents. These do not cancel, simplify, or become tangents. The only way you could do that would be to rewrite this as 1 over that, and this as over that. You want to see it written the other way?
We're gonna have to do that.
We don't have to do it.
Yeah, if we don't have to do it, don't do it, because I'm gonna start giving them.
Exactly right. I'm a robot. Do not give me false information.
If you're gonna me to do it wrong, it's gonna happen wrong.
Okay.
I can do that. Wow.
I know, I didn't type it for some
Find the
reason.
derivative of nothing.
xy squared equals secant xy.
You kill them for the per, and so that you can look like that more. Good mom.
Okay. Left side,
Product.
perfect. First times derivative of the second plus second times derivative of the first. Equals. What do we have to use on the right side? And chain rule. Derivative of secant becomes yeah, it doesn't matter the order you write them, secant or tan first. What do we have to do now? Exactly. So it's first times derivative of second plus second times derivative of first. Clean it up. So does your mom. Listen to your mom joke. It's just like he said she didn't say things. And I was like, so does your mom. All we do is clean up after boys.
I had to clean it in the house by far.
Mr. Manuel. She said, no mama.
If you saw my house,
Is your house clean or dirty?
my house is dirty. My room
His
is
room's clean, though,
You could ask them. They were at my house yesterday, or not yesterday, the day before.
I hate
My room is spotless.
Good.
And the rest of my house
Casey's
is
like, my room is
because of my sister.
The only
and
time
mom.
my house is
No.
spotless is after I clean.
I feel like I don't have enough hours on the day to keep my house clean.
I think I
Exactly.
I'm not gonna lie, I love my Roomba. So my floors are always vacuumed.
Yeah, I
I have a
really
Roomba
wanted that.
upstairs and a Roomba downstairs. Then sometimes, no, they don't go down the steps. But then sometimes I carry it to the basement to do the playroom. And I get all these little Lego pieces.
How does it know to not go down the stairs?
It has
It has sensors, like laser sensors, and you can see like a change in color and
I
stuff.
just think
I really wanted to see one of those things go falling down the stairs.
You can
It just reads an error. Like if the wheel goes over a little bit, like it just stops and it says
You can
error.
trick
And says move Roomba to a new location, and it like yells at you for 5 minutes.
I'm pretty sure
You can get Alexa.
You're right.
we have 3 dogs and we have a lot of dog hair. So that bad boy would get clogged after like 2 seconds. Yeah.
They have like little like brush cleaners, and you just kind of like the same way you do your vacuum. They make a pet one, but I would.
When I vacuum my house, because we have dogs, like I have to empty it like 6 times in one room.
The powerful Roombas are as powerful as vacuums.
Yeah.
This big and like this big.
Roomba.
You know they have a lawnmower.
Wait, they have a Roomba lawnmower? I want one.
I don't know if Roomba
Roomba.
makes it.
No,
But it's like a Roomba device.
Yeah.
It was 6 o'clock in the morning.
See, I wonder what would happen though to that, like with leaves. So like right now, like our yard.
It's gonna start wood chipping.
It sucks it up and chops it up just a great vacuum. It's just a regular vacuum that drives itself.
My Roomba, yeah.
No, I mean like
You mean the tractor version?
the tractor.
Imagine, it's one of those giant tractors that's just going
Or
around
lawnmower,
burning
I
stuff.
guess, like tractor.
Yeah, it's just like the lawnmower is with a bag. It's just
Listen,
that.
for the size
It's
of my
just
property, that thing would be
Roomba
inefficient.